Yeah, hi everyone. Welcome to this session on retrieval augmented generation. We will explore what RAG is and how RAG is used in generative AI to extend the capability to at enterprise level. So moving to the next slide. So hallucination problem in large language models. So why RAG is required? So hallucination is when the model LLM, when you give it some question, it gives you an output confidently, but that output is completely wrong. This is known as hallucination. So the models like ChatGPT, Gemini, all of these are trained on large corpus of data, and this data is publicly available on the public domain. This does not include the data of individual organizations. Say, for example, Siemens, TCS, Reliance, they have their own data. They have their own policies. They have their own documents. So this ChatGPT or any other LLM is not trained on that individual data. So whenever user asks any questions which are pertaining and very specific to an organization, the ChatGPT hallucinates or the LLM hallucinates because it is not able to bring the exact context. So it forms its own answers which it thinks is correct, but it is actually wrong. So RAG helps in bridging this gap. So if you consider the analogy with real world, then there is a closed book exam and there is an open book exam. So in closed book exam, the student has learnt, he has prepared, and then he comes and gives the exam. He gives the exam based on his memory, based on his understanding, and based on what he remembers. There may be some questions which he is not able to answer because he doesn't remember them or he has not read them properly. He is not trained on them. And when you give him an open book, it becomes an open book exam. So then what happens is that whatever question he is not able to answer, he will go and search in the open book. He will find the reference and from there he will write the answers. So this is what actually RAG does. So RAG is an open book exam for the student. So RAG is for the organization which is local storage of all the repositories. So RAG actually stands for Retrieval Augmented Generation. It is a framework which has fundamentally changed the way enterprises use LLM, and it has bridged the gap between LLM and enterprises. The whole generative AI craze which is going on, RAG is the enabler. Retrieval means extracting the relevant information based on the question which is asked, and augmentation means enriching the question by adding retrieved context and supporting information. And then generation. We send the retrieved context and the user question to the external LLM, which generates answers which are based on the extracted content. So this helps in producing answers which are grounded, which are free of hallucination, and which make sense for the user. For example, if someone asks in a local chatbot in the organization, what is the promotion policy in Siemens? Then this information is not readily available on the internet or on the external LLM. But if we have policies which are stored in RAG, then the relevant information can be retrieved from RAG. And then with this information, the question can be passed to the external LLM, which can give the answer according to the content which we give in the prompt. So this is where RAG is useful. It acts as a bridge between the organization and the LLM. So how RAG actually works? It is a 5-step process. So first you have to store all your company's documents in one folder. Once you store them, then you have to do semantic conversion. So basically you have to convert them into vectors which represent the contextual understanding. And then a user asks the question which is again converted into embeddings and it is matched against the data which we stored in the database. And then we get the intelligent retrieval. We get the information which is stored in database which is pertaining to the question user has asked. and this is specific to the organization. And then this content is sent to the LLM, and then LLM gives an answer which is based on the content retrieved from RAG. So this all is possible through semantic search. Semantic search is searching based on semantic meaning. It is not searching based on keywords. So it doesn't check the keywords which are present. It checks the meaning of the word and what all words are having similar meaning or meaning which is very near to each other. So cosine similarity is a concept which is used in finding out which all words are having similar meaning. So every word has its own vector, and the words which are related to each other have their cosine similarity of very near. So suppose if we have sports, so in sports the vector number will be very much close to cricket, badminton, football, because all these are type of sports. So when we search for sports, it will bring all these words based on the nearest vector number. This is how the semantic search works in actual scenario. So if you see, RAG actually helps in giving grounded answers based on your documents. So when you ask on LLM what is the Siemens promotion policy, it will not be able to answer properly. But when you ask on RAG, which has access to all the documents, it will give the answer properly, and then it will send that contextual information to LLM to giving a proper response. So it dramatically reduces hallucination rates, and it's very secure and private data source which is not exposed to the external internet. So you can build enterprise ready and compliance friendly applications with using RAG. So we have use cases in all the fields. So in financial sector, we can have a chatbot with all the financial information, documents loaded in the database, RAG database, and then you can do a search on that. It will give you some context. Then that context can be sent to LLM to get a grounded response. Similarly, we can do for healthcare. All the research papers we can add, and based on those questions, it can retrieve relevant answers from the research papers and give it to the healthcare professionals. Similarly, for legal, the contract information it can find across multiple documents and give the information. HR, it is helpful because all the policies, all the benefit systems and everything, all documents are loaded in the RAG, and then you can ask questions so employees can directly interact with chatbot rather than going to HR every time. Similarly, for customer support, so the customers can come, they can ask their questions, and they directly get the answer from the RAG. So it helps in all the fields. Wherever you want to build a local repository, a local knowledge assistant, which will give you grounded answers based on your organization's data, you can use RAG. So what is the architecture like? So we have a data ingestion layer. So in this, we take all the relevant documents, put it in one folder. Then we do the embedding generation. So we convert it into vector embeddings, chunks, and we put it into the database, vector database. And once it is there in the database, then whatever query user puts, that query is converted into embedding, and then similarity search is done on the vector database, through which we get the grounded response. This response is then, together with the question of user, is sent to LLM to form a proper, detailed, structured response. And then this is delivered to the user. So user gets the benefit of both the LLM as well as the local information of the company. So here vector databases are very important. They are the foundation of RAG. Vector databases are those databases which are optimized for semantic search, optimized for speed. Okay, so they are very much fast when you search something. They are optimized for search function. So various vector databases are Pinecone, Viviate, Chroma, Milvus, and Quadrant. Chroma is a very lightweight, you can use for POC purpose. Quadrant you can use for the actual production. It is open source and commercially free for use. So these systems support millions and billions of vectors with millisecond query latency, which makes RAG very powerful. So you can do more practice on these databases by installing them. It leads to speed, scale, and accuracy. So now we understood what RAG is. So there are some common misconceptions that what RAG is not, and people have those conceptions. So RAG does not do the training of the model. RAG doesn't have any relation with training. It's a local database. It doesn't give data to model for training. Then RAG will not modify the LLM. So LLM is something, an external entity. It will not at all influence the LLM output, neither it will modify it. It will just give the context element to the LLM together with the user question. And RAG has nothing to do with fine tuning. Fine tuning is a separate thing where we tune the weights depending on the various words and what are their vector embeddings. So RAG is not at all involved in this. It just retrieves and injects the relevant information dynamically. So advantages. We have so many advantages. It is always current because we have the latest document uploaded, so it is able to search those documents. We also send metadata information when we upload documents, so it is able to search in that particular domain. So for healthcare domain, it will not search for the documents which are there in finance domain. It will search for the context in healthcare domain only. It is transparent and auditable, so you are easily able to do the audit because you have all data available and you have transparency. It also gives citations, which actually helps in having the audit trail. It is cost effective. There is no cost associated with local search. Only the LLM tokens is what is required as a part of cost. Data is secure because it's in your own database. Then it's flexible and modular. So you can add any module tomorrow to that particular RAG. So today you have healthcare, finance. Tomorrow you want to add legal. Just take the legal documents, make chunks, put in the RAG and start using it. And it's a domain specialized system. So you can have one RAG for healthcare domain, one for finance domain, one for legal domain, one for e-commerce domain, one for customer domain. So the list goes on. So this is actually a very big advantage. It extends the LLM to the local organizations who can get grounded responses. So how to measure the effectiveness? So if you see, it increases the efficiency from 65% to 87% for domain specific queries. It reduces the hallucination part by 73%. And a latency is very fast because it's optimized for search operations. So what are the best practices? So the chunk size is something which you have to check. So what should be the chunk size, and there should be some overlap across chunks so that the context is preserved. Then you have to select the embedding model, the sentence transformer model, which will actually do the embeddings and then retrieve data based on semantic search. Prompt engineering is important because you have to write the proper prompts, then you will be able to get the right content easily. And then initially there should be a human in the loop who will review all the outputs, and wherever you need more training or more intervention, that can be done. Data governance is very important because all data resides in your local database and there should not be any user who is able to search data which is not in his domain. So you should have an access control list which actually segregates the users according to their departments and they can search only in their domain. So RAG becomes the bridge to enterprise ready AI. It brings LLMs into the enterprise. It gives you grounded responses. It reduces hallucination. So if you see, LLM is the brain and RAG is the reference library. Together they create AI systems which are both intelligent and trustworthy. RAG is the future, and you can practice this on Google Colab or any other platform. You can have download some documents, inject them into the RAG, and try to do some local search. If you have any questions, you can always write to me. Thank you so much.